Right, hello, I'm Thomas Haney from the University of the West of Scotland, and unfortunately I can't make it to ECGBL this year. Ironically, I was forced to make a choice between this and another event that's being run by the Carnegie Trust, who actually fund this project, so unfortunately I had to make a difficult choice and represent the university, but nevertheless I thought I would record my presentation for interested parties anyway. So the paper was called A Serious Game to Teach Rudimentary Programming and an Investigation into Content Integration. And I've done this project with the help of Dr. Gavin Baxter, another lecturer at the institution, and a student who's now graduated from the Computer Games Technology degree stream called Adam Stanton. And it is a Carnegie Trust research incentive project. So as part of the research incentive grant, and the idea was to have a computer game to teach these rudimentary programming concepts and to try and really improve the student experience at UWS. And as a program leader and a module coordinator at the institution, this was deemed to be incredibly important to myself. And I realise it does have implications and ramifications for universities throughout Scotland and other countries as well. But primarily it does affect, and it's going to feed into invariably my two modules called Programming of Objects and Software Development for Games, which are really rudimentary programming modules in C#. So it's to try and utilise a novel teaching approach as a supplementary formative assessment tool, particularly for class test revision. There are a number of outputs associated with the project already, but one of them is a literature review of serious games, formulation of a framework and content integration, and I'll show you that in a few moments, and development and evaluation of that game eventually in the fullness of time. But this particular paper was really focused on assessing the acceptability and trying to formulate a list of requirements for the game that was in fact going to be developed. So computer programming is a fundamental skill across many programs at higher education: computer games technology, computer games development, software engineering, business information technology, computer science. It's a highly useful skill that can lead to a very, very rewarding career, but it's also perceived as an incredibly difficult skill, a challenging skill to learn, where almost a lifetime of continuing professional development is required in order to keep up to speed, and it almost takes approximately about a decade of training to turn a novice programmer into an expert programmer. It has been noted in the literature that programming courses have some of the highest levels of attrition, and this generally tends to happen in the first or second years of degrees. Teaching computer programming is a multifaceted problem fraught with many, many difficulties, and one of the things that we're kind of seeing is that we're not sufficiently suitably preparing graduates for jobs in the software or games industry sectors. So serious games can be perceived as a solution to that. They've been empirically evaluated qualitatively and quantitatively in several areas, including business, computing. I've written a number of systematic literature reviews in 2012, 2016, at different levels of education, such as primary education, secondary education, and tertiary education. Seeing how these things have actually been empirically evaluated, and we have done it to a considerable extent, and I really thoroughly believe, even though ECGBL is now in its 13th year, or 12th year, 13th conference, that we could probably go on evaluating games forever, essentially, in order to get the empirical evidence. So, in terms of specifically focusing on computer games being utilised for the purposes of computer programming, I did perform a rather thorough systematic literature review. I identified 364 relevant papers out of approximately 10,000, There are many, many games that have been used in this area in the past, and 251 of these papers are, not surprisingly, from the IEEE database. Baldock et al. 2014 identified 40 games used for these purposes and categorises them into type, performance, competence, topics, and language. So there's a number of serious games used in this area. Here's one here called Program Your Robot, and essentially you feed a whole load of different rudimentary commands in order to navigate the little robot through the environment. This is another one here called Code Combat, which is essentially an open source web-based serious game to learn things like Python and HTML. So they've been used in a number of ways for programming purposes. Content integration for serious games has always been one of the complex key challenges. It's far, far, far wider, I would say, than assessment integration. This was another small research topic that I looked at several years ago for this conference in 2013. And assessment integration was far more narrow, whereas content integration became incredibly broad, with very, very little research performed in this area when we're in fact talking about pedagogical content integration. Every serious game is really generally custom built, or can be a custom built learning tool. And general content integration frameworks, they generally end up being too problematic to develop because they are at a high level of abstraction and incredibly general without going into the specifics. There are different categories of content that, of course, we know about: intrinsic and extrinsic content, where intrinsic, the game is more or less inextricably interconnected to the pedagogical content in some way. So, for example, a CSI might be solving a crime in a sort of CSI game. You of course get the extrinsic content, where the learning content is a little bit separate, where you play the game and then you get to the learning content, or get to the learning content and play the game as a reward. And that kind of links in with WEN's 2009 endogenous and exogenous categorizations of games. So it has been noted that there is research lacking in terms of how computer games are used in teaching with regards to acceptance by students, and in particular regards to referencing the curriculum and the pedagogical content integration. So I don't think it's quite accurate now to say that there's a dearth of empirical evidence in terms of proving if games-based learning and serious games are effective, but there certainly is a dearth of empirical evidence looking into the pedagogical content and actually surveying learners to see how that content can then be incorporated and assimilated into a game. So here's my framework that I came up with for content integration, taking into account assessment, informative and summative assessment, some of the references there, the types of game, whether that's going to be 2D game or particular genre format. The particular computer science curricula is important as well, whether that game is going to be single player, multiplayer, so all these things have to be kind of taken into account, and you've got to ask what the requirements are. Whether that's going to be a high level language that you're teaching, low level language, perhaps program agnostic. Acceptance and content, the reference that I showed you in the previous slide. Guidelines for the integration of the particular computer science education content, and how to actually integrate abstract concepts as well. So these are all problems for integration of content. So in terms of trying to get some basic rudimentary requirements for a game that we were going to create, managed to get a little bit of research funding on this, and managed to get a nice sum of it at £8,000. So it was considered a viable option to develop a game, hire a good game developer from the course, and try and develop an assessment game for programming. So the questionnaire purpose was research is lacking in terms of acceptability or acceptance. and specifics regarding the curricula and pedagogical content. So in terms of engaging, to gauge acceptability, 75% of the participants found that this was an acceptable course of action, so 25% really didn't. And it was to formulate a list of starting requirements for a game to teach programming, so programming content in terms of rudimentary, advanced data structures and algorithms, what particular game genre that should be in terms of platform and graphics, and to see what particular topics the students or learners felt should go into this. Now, one kind of major trend seemed to be that the easiest topics were considered more suitable to be taught by a game, which is possibly something to do with the student's ability to perhaps visualize that. So it was constructed by a number of from a number of books and a number of programming courses. 55 participants were male, the rest were female. 61 participants completed the questionnaire in total. They played games they were computer game students, so 17.5 hours a week, which is quite inordinately high. And they performed possibly about 11 hours of independent study. They'd been learning computer programming for about 3.1 years, and those are their individual streams. 30 participants were in their first year of study, 11 participants were in their second, 7 were in their third, and 13 were in their fourth. So in terms of effectiveness of teaching approaches, I asked how effective these particular teaching approaches, current teaching approaches, were for teaching computer programming. Now, I couldn't really have done this if I tried. One of the questions was in fact to ask how effective these particular approaches were, and one question was to ask how motivational these particular teaching approaches were. And as you can see, they're absolutely 100% identical, and I don't really think that I could have done it if I tried. So the most effective sort of teaching approach for programming is obviously the practical lab sessions, individual group projects, and classroom tutorials, with the paper-based stuff and role-playing and live-through case studies being at the bottom. Now, it was considered quite useful to see exactly, for the purposes of my course and for the purposes of this paper, to see exactly how difficult students found particular concepts. So in terms of rudimentary concepts such as smart pointers, parameter passing, and overload functions, these were considered to be the most difficult topics in rudimentary programming, with declaring variables, variable types, conditionals, loops being rated the easiest. Again, with more advanced programming difficulty, aggregation and association, composition and polymorphism, no real surprise there, were seen as the most difficult or highly rated in terms of difficulty. With defining classes, constructors, inheritance, and setting member access levels and data members being at the bottom of that particular ranking. In terms of data structure difficulties, not surprisingly, game trees, minimax trees, binary search trees, binary trees, and graphs were the most difficult, and arrays, stacks, and standard vectors were considered to be the more easiest concepts. Algorithm difficulties, no great surprises there. Bubble sort, quick sort, heap sort were considered to be the more easy of the searching algorithms. So in terms of programming concepts to actually be incorporated into the game, the students or the learners surveyed said that conditionals, logical operators, variable types, loops were considered to be more appropriate, and the more difficult concepts were considered to be less appropriate. This was probably due to visualization. In terms of advanced programming concepts, inheritance, defining classes, setting member access levels, they were considered better for incorporation into a game. And aggregation and association and abstract data types were considered to be less suitable. In terms of data structures and algorithms, arrays, queues, stacks, multi-dimensional arrays, they were considered to be better for a game. And binary search trees, binary trees were considered to be less suitable. This is probably indicative of the students' level, because I have found examples in the literature of games utilising binary search trees in quite an abundance.
In terms of algorithms, the basic pathfinding, because it is games related, bubble sort, merge sort, heap sort, we consider more incorporatable into a game. And then in terms of the type of gaming platform, they were given a number of genres to choose from, and the most popular seem to be educational, puzzle, simulation, serious adventure game, with racing games and sports games being the least popular. In terms of the format, which is a little bit surprising, because I would have really expected more emphasis on the mobile technology or virtual reality at this stage, but it does seem that the personal computer, possibly due to the context that the student will be learning in, seems to be the most popular choice for delivery of the game. In terms of the graphics, participants were asked whether they thought it would be better to have a 2D, a 3D game, or whether that really mattered. And 80% indicated that it didn't really matter. So they were also asked about levels of graphical fidelity as well, and they said that they prefer a kind of medium level of fidelity, which is relatively surprising with all the immersive high fidelity 3D interactive learning environments that you get nowadays. You would have expected them to want high fidelity graphics and things like that. So in terms of a requirements summary, 75% of participants believed a game for computer programming would be a good idea. In terms of rudimentary concepts, in order to teach conditionals, logical operators, variable types, loops, and objects should be assimilated, incorporated into this game that is going to be developed. In terms of advanced programming concepts, inheritance, defining classes, setting member access levels were the most suitable topics. Data structures, multi-dimensional arrays, standard vector stacks and arrays, and algorithms, basic pathfinding, bubble sort, quicksort, etc. The genre of game was educational game, puzzle, simulation, serious adventure game, and the graphics did not really particularly matter, with medium fidelity and the PC format. So the simpler concepts were really considered to be more suitable to be taught by a game. And this is a screenshot of the game that we've in fact produced. It's been developed, it's done, so a next ECGBL paper or presentation will probably be the evaluation of this game as a formative assessment tool. And as you can see, level 1 is the rudimentary concepts, advanced concepts, I believe it's data structures or algorithms, and all of the particular subject areas in terms of rudimentary programming concepts, variable types, conditionals, logical operators, loops, and objects have been put in there. So it's really in the narrative of keeping a ship sort of running, and you've got a little bit of narrative there saying in order to keep the ship running and pass your test, that you've got to answer these questions. You can see the ship there. This is a very, very simple Boolean answer that's required, and the player can simply input these things. We've done it in two sorts of ways. We've done it in a sort of quiz sort of way where the player can shoot an answer, and it's also kind of slightly written to the story and narrative in order to progress in the game as well. So it's done in two different sorts of approaches. This is just really shooting the answers. You shoot these blocks out of the way, and you're confronted with a particular question covering various things, and then you've got to shoot the answer. So that's really the presentation of the project as it's gone thus far. The next stage will be to evaluate this game. And if you've got any questions, here are all my references that I used throughout the course of the presentation. And if you have any questions, then please feel free to email me or contact me at thomas.haney@uws.ac.uk. And I believe I've got 20 seconds left, so thank you very much.